Alright, in this video we're going over the binomial theorem. Your early cue for this lesson is how do you expand a binomial using Pascal's triangle and use the binomial theorem. Here's your vocab. Expand. Expand is the process of taking a plus b quantity cubed and writing it as 1a cubed plus 3a squared b to the first plus 3a to the first b squared plus 1b cubed. We'll get into that more in a little bit. But that's what I mean by expand. You take a plus b quantity cubed and you actually expand it out or multiply it out. Now, Pascal's triangle is a triangular array of numbers in which the first and last number of each row is 1, and the other numbers in the row is the sum of the two numbers above it. And here is a picture of Pascal's triangle. Row 0 is just a 1. Row 1 is a 1 and a 1. Row 2 is 1, 2, 1. Remember, it starts with 1, ends with 1, and the number in the middle is the sum of the two above it, where the two above it is 1 and 1. 1 and 1 is 2. So now this is 1, 3, 3 and 1 because it starts and ends with 1. 2 and 1 is 3. 2 and 1 is 3. And then here we have 1, 4, 6, 4, 1. Starts and ends with 1. 3 and 1 is 4. 3 and 3 is 6. 3 and 1 is 4. And so on. Now, this is only the first 8 rows. Of course, this Pascal's triangle can go on forever. But you probably won't need it past 10 for this class. And for this video, you won't need it past 8. So make sure you go ahead and write this down because I am going to refer back to this. So make sure you have it in your notes so when I refer back to it, you have it to look at. And then the last vocab word is the binomial theorem, which gives a general formula for expanding a binomial. All this means is this. You have a plus b quantity raised to the n power. All that means is you're going to take that power, find the corresponding row number. Like say this was a cubed, you'd go to row 3, and your coefficients of your polynomial, the coefficients on your x's will have a 1, a 3, a 3, and a 1. We'll go over that more in just a second. But that's basically what the binomial theorem says is these p's here, p1, p2, pn minus 1, and pn, that's just you're taking the exponent, finding that same row in Pascal's triangle, and you're going to use those numbers for coefficients. All right, using Pascal's triangle. What is the expansion of the quantity a plus b raised to the 6th power? Use Pascal's triangle. So if you notice here, it says the exponents for a begin with 6 and decrease to 0. Right? So we have a plus b. Now remember, these will be letters, like this could be x plus 3 or something, but we won't get into that yet. We'll just use the letters. So if you go to the 6th row of Pascal's triangle, you notice it's 1, 6, 15, 20, 15, 6, and 1. So you're going to start out with those numbers. 1, 6, 15, 20, 15, 6, and 1. Now, since this is a 6th-degree polynomial, you're going to start out with a to the 6th, b to the 0. Okay? A to the 6th, b to the 0. Remember, b to the 0 is 1, so this term basically doesn't exist, this b to the 0. And for your next term, you have your 6, and then you're going to subtract 1, so you're going to have a to the 5th, then you're going to add 1 to the b, so you're going to have b to the 1st. Then you're going to keep going, plus the 15, remember that number's from Pascal's triangle, a to the 4th, b squared, I just subtracted 1 there, and I added 1 there, plus 20, again from Pascal's triangle, a cubed, b cubed, plus 15, a squared, b to the 4th, plus 6, a to the 1st, b to the 5th, plus 1, a to the 0, b to the 6th. And if you remember, this a to the 0 again is just 1, so it technically isn't there. So this is what the polynomial would look like. A plus b to the 6th equals a to the 6th, because you don't really need the 1. A to the 6th plus 6, a to the 5th b, plus 15, a to the 4th b squared, plus 20, a cubed, b cubed, plus 15a squared b to the fourth plus 6ab to the fifth plus b to the sixth. So, as you can see, you just use the 6. The binomial theorem says go to the sixth row of Pascal's triangle, and you're going to take those numbers, so 1, 6, 15, 20, 15, 6, and 1, if you look back at your Pascal's triangle. Then you take whatever a is, raise it to the sixth, and then to the fifth, the fourth, the third, the second, the first, and of course the 0, so you don't put it here. Then you take whatever b is, b to the 0, so it's not really here, and then b to the first, b squared, b cubed, b fourth, b to the fifth, and b to the sixth. That's all Pascal's triangle. That's how you use Pascal's triangle, and that's all the binomial theorem says. All right. So I want you to expand this one out just like we did, just like we had the one before. So what is the expansion of a plus b quantity to the 8th? Use Pascal's triangle. So pause the video and figure this out. All right, so this 8 says we're going to use the 8th row of Pascal's triangle. The 8th row of Pascal's triangle is 1, 8, 28, 56, 70, 56, 28, 8, and 1. All right, so start by writing those down. Then we're going to start out with a to the 8th, and we're going to drop one. A to the 7th, a to the 6th. I don't know if I left myself enough room. A to the 5th, a to the 4th, a cubed, a squared, a, because we don't really need to write the 1, and 8 to the 0 is just 1, so I'm not going to write it. Now we take the b and do the same thing. This is b to the 0, so I'm not going to write it, and this is a positive 8, so I'm going to go ahead and put in my plus sign now. Now we're going to have b to the first. Again, you don't really need the exponent. And then this is going to be, since that's b to the first, this is b squared, and that's a plus 5. And then this is b cubed, and that's a plus sign. B to the fourth, and that's a plus sign. B to the fifth, that's a plus sign. B to the sixth, that's a plus sign. B to the seventh, that's another plus sign, and b to the eighth. So this is what your polynomial should look like expanded. Now again, you don't have to have this one, and you don't have to have this one either if you don't want them. And if you wanted to write the b to the 0 there and the a to the 0 here, for now that's fine, but on a test, I'd want you to leave them off. All right. Now, something else I want to point out here. This is to the 8th power, okay? We use the 8th row of Pascal's triangle. Now, the 8 also comes in one other place, all right? I'm going to go ahead and write in the b to the 0 here and the a to the 0 here. And I'm going to put the 1 on the a here and the 1 on the b here just to explain this part. Add these two exponents on a and b. What's 8 and 0? 8, and that's what our exponent is. 7 and 1, 8. 6 and 2, 8. 5 and 3, 8. 4 and 4, 8. And as you can see, 8, 8, 8, 8. The exponents will always add to whatever your exponent is here. These two exponents will always add to that number as well. So if you're writing them all out and you run out of letters here and you're like, what happened? Like say this was a to the 0 and you're like, oh, I left one out. Just go back and make sure that all your exponents add up to what this exponent is up here. If you find one that doesn't, that's where you made your mistake. All right. Let's do this now with actual numbers. It's probably what you've wanted the whole time, which is fine. I like numbers better than letters, but sometimes you just need to use letters to explain the concept. So what is the expansion of 3x minus 2 raised to the 5th power? Use the binomial theorem. So we can also use Pascal's triangle. So we need to go to the 5th row of Pascal's triangle. So the 5th row of Pascal's triangle is 1, a positive 5, a positive 10, another positive 10, another positive 5, and a positive 1. All right, now, remember we take a, which is this first term, 3x, we raise it to the 5th. So 3x to the fifth, and then 3x to the fourth, and then 3x cubed, and then 3x squared, and then 3x, and of course you don't have to write it there because it's going to be 3x to the 0, which is just 1. Now do the same thing with the negative 2. Negative 2 to the first is just going to be 1. I mean, negative 2 to the 0, sorry, it's just going to be 1. Negative 2 to the first, negative 2 squared, negative 2 cubed, negative 2 to the fourth, and negative 2 to the fifth. All right, now you just go back through and do your multiplication. All right, 3 raised to the fifth power is 243. And then, of course, x to the fifth, because you can't forget about your x to the fifth. And, of course, the 243 times 1 is just simply 1. All right, so now plus. We have to go 3x to the fourth. Well, 3 to the fourth power is 81. So this is going to be 81 times 5, which is 405. And now we have to multiply by the negative 2, which comes out to negative 810. So this plus sign here will have to go to a negative sign. We have negative 810, and of course, x to the fourth. All right. Now, do the same thing here. We know that 2 squared is 4, so we know this is going to be positive because negative 2 squared is positive 4. So 3 cubed is 27 times 10 is 270. And then negative 2 squared is 4, so 270 times 4 is 1080. And then, of course, x cubed. And then here, negative 2 cubed will leave us with a negative number, so we're going to have a negative sign here. So, oops, that's not supposed to be in there. That's supposed to be out here. So 3 squared is 9. 9 times 10 is 90. Negative 2 cubed is negative 8. And 90 times negative 8 comes out to negative 720. And of course we have x squared. And then plus, because negative 2 raised to the fourth will give us a positive number. So now we have 3 raised to the first, which is just 3. 3 times 5 is 15. And then 15 times negative 2 to the fourth is simply 16. So that will leave us with a positive 240x. And then negative 2 raised to the fifth power will be a negative number. And negative 2 to the fifth is negative 32. So our polynomial, we'll call it p of x, equals 243x to the fifth minus 810x to the fourth minus 1080x cubed minus 720x squared plus 240x minus 32. All right, so you just use Pascal's triangle like we did. Since this is a fifth, since this is the exponent here is 5, sorry. Since the exponent here is 5, we're going to use the fifth row of Pascal's triangle, which is 1, 5, 10, 10, 5, and 1. Then we're simply going to go take a and raise it to the fifth power, so 3x to the fifth, and then keep going, dropping your exponent. 3x to the fourth, 3x cubed, 3x squared, 3x to the first, and of course 3x to the 0 is just 1, so we left it off. Then you're going to do the reverse with the negative 2. You're going to start out with negative 2 to the 0, which is just 1, so we left it off. Negative 2 to the first, negative 2 squared, negative 2 cubed, negative 2 to the fourth, and negative 2 to the fifth. And if you look, all your exponents add up to 5. This adds 5. 4 and 1 is 5. 5, 5, 4 and 1, because it's technically 1 is 5, and then you're 5. Then you just simply do your math for each individual term. 3 to the fifth is 243 times 1 is still 243. 3 to the fourth, all right, you do 3 to the fourth times 5 times negative 2, and that comes out to negative 810. You go 3 cubed times 10 times negative 2 squared. 3 squared times 10 times negative 2 cubed, 5 times 3 times negative 2 to the fourth, and then negative 2 to the fifth. And of course, your variables and their exponents will simply be x to the fifth, x to the fourth, x cubed, x squared, x, and then none. All right? So, not too bad. I'm going to give you an example to try on your own here in a second. But this is not too bad. You just use Pascal's triangle to get your initial coefficients. So 1, 5, 10, 10, 5, 1, because that's the fifth row of Pascal's triangle. Then you simply use the pattern that I showed you. A to the fifth, b to the 0, a to the fourth, b to the first, a cubed, b squared, a squared, b cubed, a, b to the fourth, and then of course a to the 0, b to the fifth. This being your a term, and then negative 2 being your b term. Okay? So give this one a shot. What is the expansion of 2x minus 3 to the fourth power? So pause the video and work that one out. All right. So if you go to the fourth row of Pascal's triangle, your coefficients are 1, 4, 6, 4, and 1. Hopefully you got those right. And of course, put some plus signs in front of this because initially it's all positive. Now we're going to do 2x to the fourth. So 2x to the fourth. Remember, there's no reason to do the negative 3 to the 0 because that just equals 1. If you wanted to do it, that's fine, but you don't have to. And then we go to the second term. We're going to have 2x cubed times negative 3 to the first. Again, you don't have to write that one if you didn't want to. And then you keep going. 2x squared times negative 3 squared. Then you're going to have 2x to the first, negative 3 cubed. Then you're going to have 2x to the 0, which I'm not going to write. And then you have negative 3 to the fourth power. All right. Now we just got to simply do the math to get it simplified down. Well, this one isn't going to do anything, so 2 to the fourth is 16. So p of x equals 16x to the fourth. Now we move on to this one. 2 cubed is 8. 8 times 4 is 32. 32 times negative 3 is negative 96. And of course it's x cubed. And then plus, because negative 3 squared would give us a positive number, and the rest of these is positive. 2 squared is 4. 4 times 6 is 24. 24 times 3 squared, which is 9, comes out to 216. And of course it is x squared. And then our next is going to be minus, because negative 3 cubed is going to be a negative number, and these are positive. Positive times negative is negative. So 2 to the first is 2, times that is 8. And then 3 cubed is 27, so 27 times 8 is also 216. And then it's going to be x to the first, or just x. And then plus, because when you raise a negative number to an even power, it always comes out even. Negative, so negative 3 to the fourth is positive 81. So that is your polynomial you should have gotten. 16x to the fourth minus 96x cubed plus 216x squared minus 216x plus 81. Okay? So that's it for the binomial theorem and Pascal's triangle. It's not too bad. Make sure you wrote down the Pascal's triangle that I showed you on the second page, the vocab page, because that you will need that, and that will come in very handy when you're doing your work on this tomorrow. All right. So just a quick to review, you can easily solve these by using Pascal's triangle. You match your exponent up here to the corresponding row in Pascal's triangle. Those are your initial coefficients. So in this case, the 1, the 4, the 6, the 4, and the 1. Then you simply you take this term and raise it to this number, so 2x to the fourth, and then you drop an exponent until you run out of exponents. 2x cubed, 2x squared, 2x to the first, 2x to the 0, which again is just 1, so I left it off. And then -3, you start with 0 and you count up to this exponent. So -3 to the 0, again, is just 1. I left it off. -3 to the first, -3 squared, -3 cubed, and -3 to the fourth. And again, the exponents of each term will always add up to the exponent here. So this is 4 and 0, which is 4. 3 and 1 is 4. 2 and 2 and 4. 3 and 1 is 4. 4 and 0 is 4. All right? So that's it for binomial theorem. Feel free to watch this video as many times as you need to. Make sure you come to class tomorrow ready to work some problems. See you tomorrow.